So the character is the dummy that we're looking at right now. It is the model we control when we play the game. It contains the location data, character components, and character attributes. The player is just logic. It does not exist in 3D space. It contains player-specific variables, limited components, and gives us access to different classes. Anything that you interact with physically in the scene is when you should be using the character entity. For example, the entering collision event is triggered when an entity goes through it. The entering entity in this instance will be our character dummy that we control. So if we plug this into something that can directly affect our character dummy, in this case, let's say we wanted our character to lose health whenever it enters. Now we can see that whenever we enter the collider, we take damage. What you should not do is use getPlayerEntity to which the character belongs, because, remember, the player does not physically exist in the scene and does not have these attributes. So if we ran this, it wouldn't work because, again, the player does not physically exist in the scene and it only exists in logic. Another thing that exists in the scene is the tab component, and when we interact with it, we get registered as a selector entity, which means that the selector entity is a character entity because our character entity is the one that interacts with the component. So now, whenever we select the tab, we'll lose health. We can use a player entity to keep track of certain variables, switch to a different character class, and use graphs that specifically require the player entity. As a quick example, let's make a score variable in the player tab. In order to actually see our score being changed, go to the UI section, click on Add a UI Control, click the prefabricated template dropdown, then select text box. Then in the text box settings, type in score, followed by a colon and a space, and click Insert Variable. Then in the dropdown, select Player themselves and choose the score variable. We can then reference this variable in the node graph by making use of the player entity. Make a node graph and call it whatever you like. Create an event node that checks for player collision and attach the entering entity output to the character to player converter. Now with our complete graph, whenever we enter this entity, our score will increase. So let's attach this node to an object and give the object a collision trigger. And as we can see, our score correctly goes up whenever we enter. Now, as I've mentioned before, the player entity does not have location data, but if you use a node like this, which requires the player entity, you'll notice that it appears like we can modify the player's position, but we aren't. All this does is use the player entity as an input so we can modify the character's position.